Um, yeah, most people, yeah, there's usually drop off, and then people start panicking right around week 9. So 8 kind of goes down, 9. So yeah. All right. Yesterday I passed out some practice, just the end of the stuff from chapter 7. It was all about the distributive property. If you want some extras, there's some extras up here if you didn't get it. I'm going to go over the solutions to that one. Then we're going to jump into chapter 8. And chapter 8 is all about equations solving. And we've already solved equations, so now we're just going to add in some of these new properties that we've discussed into the equation solving. So, all right, so let me pull up a screen here. All right. So, looking at the one we did yesterday, they started off not too bad, got a little more complicated as they went. So the first one was 4 times x plus 8. So to get rid of those parentheses, we would want to distribute that 4 through, yeah? And so then that would become 4x, and then 4 times 8 is 32. Yeah? Okay. I'm just going to kind of go through these. Just stop me if you have questions. All right, so then the next one over, we got 7 times 3p minus 8. So that 7 needs to get distributed to both terms. You multiply the coefficients together, so 7 times 3 is 21. Now this is positive 7 times minus 8. Remember, those signs are attached to the terms. So 7 times minus 8 is minus 56. Does that answer your question, Jennifer?
I don't think so, but let's
Okay.
keep going.
Yeah. So the signs are attached to the terms.
Okay.
So what's that?
Yeah.
This one? Yeah. So this 7 is positive. This is a positive 3p term. This is a minus 8. So when I distribute the 7 through, so here the 7 times 3, positive, 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 21p. Here, this is a positive distributed to a negative term. Positive times a negative stays negative, and 7 times 8 is 6. Yeah. So the signs are attached to the terms. That's the key. And as long as you keep those signs attached to those terms when you distribute them through, or when you write the answer down, you're always going to get the operations right.
So, like if this were on the final, this exact problem.
Yes.
Okay, so then, are we then having to solve 21p minus 56, or that is the answer?
So very important, very important. You look right here, where it started, no equal sign.
No.
It's not an equation, right?
Mm-hmm.
This is an expression.
Yeah.
So if there's no equal sign, we can't solve it. There is no answer to this. It's just an expression that can be simplified.
Okay.
So if there's like terms, you can combine them and all that stuff,
Okay.
but there's no solution to an expression.
Okay.
It's just the algebraic expression.
Okay.
You know, if I gave you a value of p, and I said evaluate this at p equals some number, then you could put it in there and then simplify. You get one number. But as long as that's not the case, it just says simplify. Yeah, there's not a solution to this. Yeah, p could be any number at this point. Okay. Okay. Now, sometimes it gets tricky with fractions, but you just need to remember how you multiply whole numbers times fractions, right? So when I multiply 1/4 times 3, that one's not as hard. What is that going to give me? Yeah, so exactly. When you're multiplying a whole number times a fraction, essentially the whole number just gets multiplied in the numerator. Okay? So then you multiply by the numerator. You can simplify it if possible. This one you can't simplify. So 1/4 times 3 is just going to be 3/4. So that would be 3/4 cubed. Now, when I distribute it there, it's 12 times 1 on top is 12 over 4, but that simplifies, right? Because I'm doing, right, because 1/4 times 12 is like 1/4 times 12 over 1, right? And what is 12 over 4 simplify to? Yeah, because 12 is divisible by 4. So that's going to go all the way down to 3. And so your answer would be like that. Okay. So when you multiply a whole number times a fraction, you you just multiply the whole number to the numerator and then you simplify. In this case, 12 times 1 is 12, divided by 4, that happens to give us 3. Because that one simplifies the whole number. Okay? All right, then we got negative 3 times x minus 6. And now remember, this negative is attached to that 3. So when you distribute it in, negative 3 times an x term, that's a negative 3x. Then when you distribute it to this term, this negative is attached to that 6, so negative 3 times negative 6 is positive 18. Yeah. Yeah. Okay. All right. So does that make sense then? Okay. Yeah. The sign is attached to the term. So if you move those terms around, you multiply them through, you do anything with them, the sign goes along. All right. Okay. If you just have a negative outside, how do you treat that? Yeah, you treat it as a negative 1. So you basically just put the negative through, and all it does is it just flips the sign on everything. Think of this as like a negative 1 times. Negative 1 times 3, that just turns to 3 negative. Negative 1 times negative 7, it just turns to negative 7 positive. Anytime you distribute a negative number through, it basically just flips the sign on everything. All right. And that expression on its own is not particularly common, but what you do see a lot of times is you see things like that embedded in other expressions, like the next one, where it's a minus 11 times 3c minus 2. And so when I put this 11 through, I'm not putting just 11 through, I'm putting the minus 11 through. Yeah. So the 4 stays a 4. You got minus 11 times 3c, so that's a minus 11 times positive 3. That's a minus 33c. And then minus 11 times minus 2 is positive 22. Because remember, these signs are attached. Yeah, the 4 is already out there. So that thing we're waiting, because that's just 4 minus, that's out there to be evaluated at the end. We have to get rid of our parentheses with the distribution first. Now we can identify that we have some like terms here, right? Because 4 and 22 could be combined. So you got a positive 4 plus 22, that's what? 26. And the C term is just, that's what it is, right? Okay. So far so good? Questions? Okay. This one, so we got 5m minus 3 minus m plus 7. Now, do we even need the parentheses on that first chunk? We actually don't, right? Because there's nothing being distributed through to that. So those actually are redundant. But the second parentheses we do need to take care of because what's in front of them? This minus. So the first parentheses aren't necessary. But the second parentheses, to get rid of those, we have to distribute the negative through. So it's going to flip the sign. It's going to turn that positive m to a minus m. It's going to turn the plus 7 into a minus 7. Okay, now we've got m terms. Yeah? So I got 5m minus m. So if I got 5 of them, I'm going to take away 1. How many am I left with? 4 m's. And then I've got a minus 3 minus 7. So if I'm at minus 3 and I take away 7, where am I going? More negative. Minus 10. Yeah, it's basically adding in the negative direction. We're starting negative and going more negative. All right. Questions on that one? Okay. All right. The last one though, those first set of parentheses are important because that 14 needs to get distributed. All right. So the 14 needs to get sent through. So 14 times c is 14c. 14 times minus 1 is minus 14. I put the 14. Now we got to put our negative 8 through. So negative 8 times c is minus 8c. Negative 8 times negative 8 is positive 64. Okay, so now we've got to clean this up a little bit because we've got some C terms. So I've got 14 C's, and I got minus 8 C's, so that would leave me with how many C's? 6? Yep, 6C. And then here now I've got minus 14 plus 64. So if I'm at minus 14, I add 64, what are we really doing here? Where's this going to land us at? Positive 50. Right, because that's really the same as 64 minus 14.
Where'd you get 64?
Because...
The second 8 is supposed to be 6.
Oh, is it different on my paper?
Yeah.
Oh, well, that will change this. I wrote it down wrong? Oh, yeah. Yeah, well, that'll make a difference. Yeah, so actually the way it was written on the paper was like C minus 6. Yeah, good question. So that would be 14C minus 14 minus 8C plus 48. Yeah, so that'll change that value. So the C's don't change, you still got 6C. And then minus 14 plus 40. 48 minus 14 is what, 34?
Yeah.
34, so that would actually be the answer. That's the actual one from your paper. You can just kind of... Okay. All right. How do you guys feel about those? Relatively decent? Okay. All right. As far as we talked about a little bit about multiplicative inverses, or just basically reciprocals. So 8, the multiplicative inverse. So 8's like 8 over 1. So the multiplicative inverse would be 1/8. Yeah? If you go for 7/12, that was pretty straightforward. You just flip it. The one with negative 0.2, you may want to convert that into a fraction because that's negative 2/10, which you could reduce to negative 1/5. And so the reciprocal would be negative 5 over 1, which is just negative 5, actually. So the other thing, I mean, you could also plug it in your calculator, because you could just do 1 divided by that, and it'll give you negative 5. Because reciprocal is basically just 1 over. And then negative 3/10 just gets flipped to negative 10/3. Okay. So the multiplicative inverse or the reciprocal just means flipping. Well, if you're trying to flip it, you can just say, well, you can turn it into a fraction first, because that's 2/10, which is reducible, effectively, as 1/5. But then you just flip it. So 1/5 would flip to 5 over 1. But 5 over 1 is just another way to write 5. It's negative the whole time, though. The reciprocals, you keep your sign when you reciprocate. The sign doesn't flip. Just the numerator and denominator. What it is multiplicative inverses multiply to 1. That's what the deal is. 8 times 1/8 is 1. 7/12 times 12/7 is 1. Negative 0.2 times negative 5, try to do calculator, it's 1. Negative 3/10 times negative 10/3, positive 1. That's why they keep their sign. So that's what it means to be a multiplicative inverse. It means they multiply to be 1. So, okay. All right. So then just some properties, brushing up on properties of zeros. If you got 48 times 0, nothing wrong with that. Anything times 0 is just 0. If you have 3 divided by 0, that's a problem, right? So you can't do it. Yeah.
48 divided by 0 being
Yeah. That's times 0, though, on your paper.
Oh, okay.
Yeah. Times 0. Yeah. It's times 0. Yeah. Dividing by 0, yeah, is a problem. Multiplying by 0, no big deal. Okay. 0 divided by 3, no problem there. What's that? You are undefined. Yeah. All right. And then 5.72 divided by 0, that's not okay. undefined. So, okay. The point is, you can do anything with 0 except for divide by 0, and then that's a problem. Can't divide by 0.
Why do you say undefined?
Because it's not even a non-real number. Like, it's just not even a thing. Like, you know, we have the square root of, like, we talked about square roots can be irrational. Like, the square root of 2 doesn't exist, but it's a number. And the square root of -2 is not a real number, but it's a type of number. Like, you can actually work with square roots of negative numbers. They're called imaginary or complex numbers. We don't deal with them,
Right.
but they're numbers. Dividing by 0 is just not even possible. Like, you can't do, I mean, you can write it on the page, but you can't actually perform it. There's no way you can divide by 0. Like, because think about division. It's like, division is like how many times does 3 go into 0? Oh, no times, because it's too big. How many times does 0 go into 5.72? Like, infinitely many times, because 0 is nothing. 0 takes up no space, so you can put it into 5.72 infinitely many times. So it's like, it's infinity. It doesn't make any sense. It's not a number at all, so it's undefined.
So if any of those are on the pedestal,
Yeah, I think that's the way it's structured on the quiz. Is where, yeah, I think so. Yeah, it's like I give you options like 0, not a real number, undefined, or something like that. You have some options. Yeah. Okay. Okay. All good. So, at this point, you pretty much know everything you could possibly need to know about numbers, more or less, for the sake of probably all your math classes at CBC. And so now what we want to focus on is we've done some equation solving. So in Chapter 8, we just want to work with some equations that are maybe a little more complex. Not necessarily harder, just a little more complex. So for solving equations, we've already done some of this. So there's the one step, but everything we've done up till now has been one-step equations. So like something like, let's say you had x plus 3.7 equals 2.1, right? An equation like that. Now this one's going to have a solution because it has an equal sign, right? That's what makes it an equation. If it has an equal sign in it, then there should be an answer. All right? Now, how would you solve an equation like this?
you subtract
Yeah. I've got my x plus 3.7 over there. I'm trying to get x by itself. That's how you solve equations. You get the variable alone. Well, it's adding 3.7 over there, so how do we get rid of it? You do the opposite operation. You just subtract it. Okay. So over here, they cancel, and then you're just left with x. Over here, you just got to perform the subtraction. 2.1 minus 3.7, it's what, negative 1.6? Yeah. Okay. Fair enough? Same thing if you had an equation like 8y equals 48. There's only one operation we have to do to solve this equation. It's an 8 times y on the left-hand side, so how do you get rid of it? Yeah, multiplication is undone with division, so you just divide. You get y equals 48 divided by 8 is 6. Okay. So if addition, you undo it with subtraction. Multiplication, you undo it with division, and vice versa. If it's subtraction, you undo it with addition, whatever, blah, blah, blah. But the point is you're trying to get the variable alone, because if you get the variable alone, whatever's left on the other side of the equation will be the solution. Yeah? Okay. And solutions are values that make the equation true. So the nice thing about equations excuse me, is that you can actually check your answer, right? Like I can take this number and I can plug it back in. And I can check. Is negative 1.6 plus 3.7 2.1? Is 8 times 6 48? Yeah, it is, right? So that's the nice thing about equations, is you can always go back. You don't have to you don't have to wonder whether or not you got the right answer. You can actually plug it back in and check. Okay. Now, equations can get more complicated, but it's okay. So now what I want to do is solving equations. Now we're going to start looking at multi-step equations. Okay, so there might be multiple steps you have to take. So let's say that I gave you an equation. Let's say it was like, how about negative 2y plus 11 plus 6y equals, oh, I don't know. I think this number should be, how about, no, let's go with 47 over there. I'm making this up, so it might not turn out very nice, but that's okay. I think it's going to turn out okay. So what do you think? So there should be a number y that makes this equation true. Now, guessing and checking is a possibility, but it's not a very fun possibility. Like, I don't want to just like make up numbers of y and plug them in until I get it right. So we want to solve for this, but solving for it means we need to get the variable by itself. But what's going on here? Yeah, there's more than one multiple of y, and so what should we do? Yeah, so one thing you should always do is when you're solving equations is you need to combine your like terms. Okay? If possible. Okay. So you need to combine your like terms. So we need to combine this. So I got a negative 2y plus 6y. What is that? That's 4y, right? Okay. So if you can combine like terms, combine like terms. That should be where you should start out if you're looking at an equation like this. All right, now I've got my terms all combined. I'm trying to get my y by itself. Well, what are some things that are keeping y not by itself? Well, there's this and there's this. Well, what should I do first? Now remember though, this is 4 times y.
Oh, so divide it.
So we're going to have to divide it. Now division is tricky though, because if I divide the 4y by 4, so I would actually have to, you have to divide the whole side by, you can't just divide certain terms by 4. If you want to divide the left-hand side by 4, I'd have to divide all of it by 4, and then divide this side by 4. Okay. So typically, before we get to the division step, we want to isolate this variable term by itself. So actually what we should do is we should get rid of that 11 first. So there's a plus 11 there, and I want to get rid of it, so how should I get rid of it? Yeah, so just like before, we'll do subtraction to get rid of it. Okay, so what we'll be left with is 4y equals 47 minus 11 is 36. Okay, so there's the combined like terms, which is really important, but then the next step when you're solving equations, after you have all your terms combined, you get it down to that point, then what you have to do is you need to send your numbers to one side, right, and collect your variables on the other. So when you're solving an equation that has multiple things on both sides, your strategy is, okay, bring all of your y's to one side and send everything else to the other side. So over here, I don't have any y's over there, so I'm fine. I'm going to keep my y terms on the left-hand side, so I'm going to send all my numbers to the right-hand side. And now we can finish this by doing what? Yeah, we can just divide by 4, and then you get y equals, well, what is 36 divided by 4? It's 9. Okay, and so then the last step is you just divide the coefficient. And remember, so the coefficient, this is like the number basically on the variable term. Okay. So you combine all your like terms. Once your terms are combined on both sides, once you can't do anything more to the left-hand side or the right-hand side of the equation, send all your numbers to one side, collect all your variables on the other side, and then the very last step, you may have to divide to get rid of some number that's attached to it.
Send all your variables on one side, send your numbers to the other side. That makes me feel like I need to remember something extra. Really, like this is just the way we've always been solving.
Yeah, it's just adding more steps. It's just adding a little.
Okay, so it's not something new I need to be remembering.
Nope. No, I'm just writing down like a general strategy. But it's not anything different than what you've already been doing.
Combine like terms.
Yeah.
And then cancel what we can cancel.
Exactly.
And then get your variable alone.
Yeah.
And
Exactly.
that's the answer.
Yeah, exactly. Okay. And again, like, you know, you can check. You can check these answers to see if it's true, because you go back to where you started and you check to see, you know, is it true if I plug in a 9 here, negative 2 times 9 plus 11 plus 6 times 9, does that come out to be 47, right? Does it work? Well, this would be negative 18. This would be whatever 6 times 9, 54. Okay. And then you can add them up and see, well, negative 18 plus 11 is negative 7. 54 minus 7 is, yeah, it's 47. Right? And so you can plug it back in and actually know that, oh yeah, the answer is 9. 9 is the value that makes that equation true. Okay. Sound good? Okay. So what you may have is you may run into situations where the variables are appear on both sides of the equation, which is not a problem. So let's say that we had something like, say, 5x plus 6 equals negative 3x plus, I don't know, doesn't really matter. Let's go with 8 or something like that. So now in this equation, apparently there's some number of x, there's some value of x that you can plug in this equation to make it to the left-hand side of the same value as the right-hand side. And your answers could be fractions or decimals. So guessing and checking is just a bad idea. So we're going to follow our procedure. Now in this case, there are no like terms to be combined on either side. Right? So the left-hand side has no like terms right. So what should be our strategy now? Yeah, we want to get all of our variable terms on one side and then send all of our numbers to the other. Now it doesn't actually matter which side you send them to, because we could bring this 3x term over here, or we could send that 5x term over there. I kind of prefer to do it so that the variable term stays positive. Because see, what will happen is I could get rid of that 5x by subtracting it off both sides, but that's going to leave me with a negative x term. But to get rid of this 3x over here, I would add 3x to both sides, right? And so then it's going to keep my x term positive. Because 5x plus 3x is 8x. Over here, they cancel, and I'm just left with a positive 8 on that side. Yeah? So that's the way I would do it. I just send my variable terms to whatever side keeps them positive. That way I don't have to deal with worrying about if I'm going to lose my negative somewhere or something like that. Okay, now we're back to basically where we started at the beginning example. So now I got all my variable terms over on the left, so I need to send my numbers. Where? Where? Well, the equal sign is just coming down from the one above it. Yeah? Well, you could write the plus 8, but you don't have to, right? It's kind of redundant because it's just an 8 sitting over there. Okay. All right, so then what do we need to do now? Get this 6 out of here because I'm trying to bring all my numbers to the other side. So 8 minus 6 is 2. And then the last step would be what? Divide both sides by 8. So it looks like the answer is x equals 2/8, which reduces to 1/4. So the answer is 1/4. Or 0.25. Okay. What questions do you have on that one? Any questions on that one? Okay. The only other thing that you may run into is you may run into parentheses inside your equations, and that's why we talked about the distributive law yesterday. So I'll give you one more example, and then I'll pass out your practice problems here. So let's say you had something like 3 minus 2 times x plus, I don't know, 3 equals, say, negative x plus 7 or something like that. I don't know, whatever. Something weird like that. Why not? Okay. So if this was your equation, now we're trying, the first step is that we need to combine all the like terms that we can, but the problem here is what? The parentheses have that x term locked up inside of it and the 3 locked up inside of it, so we need to use the distributive property to get rid of those parentheses first. So there's like one extra step at the beginning. You need to use the distributive property to get rid of any of your parentheses first. Then you can follow all the other steps that we were following before. So first thing I would do is on the left-hand side, I'm going to distribute that negative 2 through. Okay. Excuse me. So that becomes what? Minus 2x. What? I'm just distributing. I'm not even paying attention to the right-hand side right now.
Okay.
So ignore this side for right now. We need to do some work on this side first. So this is just an expression. Well, how do you get rid of parentheses? You have to distribute that through. So I'm distributing the minus 2 through. So again, a minus 2 times x, that's a minus 2x. Minus 2 times plus 3 is minus 6. Right?
Yeah.
Great. So then, now we have some like terms that can be combined on the left-hand side. So what do we got? We got 3 and a minus 6. So we should put those together. Well, what is 3 minus 6? It's minus 3, right? Okay. Fair enough. Now we don't have any more like terms to combine, so what should we do now?
So now you can do that.
Yeah, we need to get all our variables on one side, all our numbers on the other. Now in this case, we could either send this negative 2x over there, or we could bring that negative x over here. Which way is going to leave the x terms positive? Because that's how I prefer to do it. So you can think about it. We're either going to add an x to both sides to get rid of this thing, or we're going to add 2x to both sides to get rid of that thing. I would send this term over there. Why? Do you know why I do that? Because it's going to keep the x term positive. So I'm going to send my x term over to the right-hand side, my 2x. So over here, I'd just be left with negative 3. And over there, minus x plus x. So this is 2x's minus 1x. I'm just left with x. So I send my variable terms to the side that keeps the variable term positive. If we would have done it the opposite way, if we would have added x to this side and added x to this side, we would have been left with a minus x on the left-hand side.
Go backwards a little bit.
Yeah.
Okay, so the second step, like we get, it's you distributed the negative 2
Yeah.
to both. Okay, so then underneath that, why do you have now negative 3 minus 2x?
Because I combined these two terms.
Oh.
Because they're like terms. So 3 minus 6 is negative 3. Yeah. Yeah. Mm-hmm. Yeah. All right. Other questions on that one? Now we got our variable on the right-hand side, so we just need to send that 7 over to the left. Well, how do we get rid of it? We subtract it. And so it looks like the answer is negative 10. Because minus 3 minus 7 would be negative 10. All right. So if you see parentheses, use the distributive property to knock them out. Collect all your like terms. Send your variables to one side. It doesn't actually matter which side, but I like to keep them positive. Collect all your numbers on the other, and then boom, you got your answer. Okay. So I got some practice here. We're going to do lots of equations, but here's just something to start out with. And some of these are a little more complicated than others. So just give them your best shots.